Salam and good day to everyone. I created this video to explain tutorial 5 of KT14203 Computer Architecture and Organization. In the tutorial, you are given a two-way set associative cache that has 4096 lines with a total size of 32 kilobytes, and you are also given a memory size of 2 megabytes as shown in the figure. So the first question is you are needed to determine the length of the memory address. So how many bits are needed for addressing a space in the memory? So as already explained in the lecture, in order to determine the length of a memory address, you need to know the size of the memory, which is also been given in this question. So the main memory size is 2 megabytes or 2 to the 21 bytes. Therefore, to uniquely identify each byte space, we need 21 bits, and the memory address must be 21 bits wide. The second question asks you to determine the size of the length of the tag, set, and word fields in the memory address, since we are using set associative cache mapping. So we start with a 21-bit memory address, since the main memory size is 2 megabytes. And we also have a cache of 32 kilobyte with 4096 lines. To determine the set, what is the length of the set? We have 4096 lines, and we also know that the cache is using two-way set associative. Therefore, we need to know how many sets are there. So the number of sets is 4096 lines divided by two ways, and we have 2048 sets, and 2048 sets is equivalent to 2 to the power of 11. Hence, we need 11 bits. We allocate 11 bits for the set. While for the word, we need to know the size of the cache line. So the cache line size is equal to the cache size divided by the number of lines in the cache. And we know the size of the cache is 32 kilobyte. And there are 4096 lines in the cache, so we divide 32 kilobyte divided by 4096 lines, and that leaves us with 8 bytes per line. So the size of each line is 8 bytes, and 8 bytes is equivalent to 2 to the power of 3. So therefore we need 3 bits for the word, and that leaves the tag field. Okay, so since the length of the memory is 21 bits, and we have 11 bits, we allocated 11 bits for the set and 3 bits for the word. Therefore, we have 7 bits for the tag. So the memory address format is as shown below: 7 bits for the tag, 11 bits for the set, and 3 bits for the word. The third question requested you to identify the values of the tag, set, and word given a memory address. So in this question, you are given a memory address in hexadecimal format, which is 1EF34R. So for this question, of course, you need to first convert the address from hexadecimal to binary. Okay, so each hexadecimal digit will generate 4 binary bits, but please remember, you have to comply with the address length when you convert the hexadecimal number into binary. Since in this example, the length of the address is only 21 bits, therefore you must trim the address from 24 bits to 21 bits. So the number that you can trim, the bits that you can trim, is on the left hand side, not on the right hand side, as shown in this figure. So once you remove the 3 most significant bit on the left, so this is the actual or the correct representation of the address in binary. So now you have only 21 bits, which is in compliance with the length of the memory address. Alright, so from the 21 bits address, you know that 7 bits are allocated for the tag, 11 bits are allocated for the set, and 3 bits are allocated for the word. So all you have to do is to split the binary representation of the address according to this division. So this is the binary representation of the address. So I already color code the address according to the format. So the blue colored representing the word. So the 3 bits on the right belongs to the word. Okay, so 010, and then the next 11 bits belongs to the set, colored in purple, and the remaining 7 bits for the tag. So what you need to do next is to highlight what is the value for the tag. So in this example, the tag is 1111011. If you want to convert them back into hexadecimal, is welcome. So in hexadecimal representation, again, you need to make sure that you have sufficient 4 bits on the right hand side of the binary representation instead of on the left. So you have 1011 on the right, which is B, and 111 on the left, which is 7. So the hexadecimal representation is 7B. While for the set, okay, you have 110, 0110, and 1001. So the hexadecimal representation is 669, and for the word 010, the hexadecimal representation is 2. So this is the answer for question 3. So what I need you to do on your part is to come up with the solutions for questions D and E and submit your answer to the ITEL before the deadline. Thank you and good luck.